How would you determine if 7 is a factor of 521? Without a calculator. What'd you do in your head? You just looked at it and your brain said no.
No, like I
You did division. That's what I wanted to know. You did division. So you would do this, right, in your head, old school style. You would take 521, you would divide it by 7. Right? How do we do this the long way? All the way back from like 3rd or 4th grade. I think it's taught in like preschool now, but how do we do it? How many times does 7 go into 52? Answer? 7. So I would multiply and I would get positive 49. Do I add 49? What do I do? Subtract. So what do I get? 3. Bring down the 1. Next question you ask yourself. Self does, how many times does 7 go into 31? 4 times, right? 4, multiply, that's positive 28. Do I add 28? What do I do? Subtract 28 gives me 3, right? Now, at this point, depending on your arithmetic level, you would do a couple things. One thing you would do is you could write remainder of 3. Yes? Remainder of 3. Then you learned fractions, and you would say 74 and 3/7, right? Then another point in time, then you put a 0 here, and you would bring down the 0, and you would keep going with your decimals. You would go to so many decimal places. You like this walk down memory lane? Do you remember doing all this when math was easy and fun? Right? Okay, so same thing's going to happen today. For right now, I'm going to write 3/7, or I'm going to say 74 remainder of 3. Do you know your divisibility rules? How do you know if something is divisible by 5? Just in general, like a number. This is SAT type of stuff. How do you know something's divisible by 5? Ends in 0 or 5. How do you know something's divisible by 2? It's even, so it ends in what? 2, 4, 6, 8, 0. Here's a good one. How do you know if it's divisible by 3? What was that? How do you know if it's divisible by 3? Jordan? You add the digits up. So for example, 521 adds to 8. Is 8 divisible by 3? No, it is not divisible by 3. Did you know that? That's a really, really powerful divisibility rule. If you add each of the numbers together, it'll add up to something divisible by 3. Same thing is true with 9. Some of you know that, like 81 adds to 9. 9 is divisible by 9, that kind of a thing. That's one of those wonderful rules of math. Okay? The other ones like 7, 13, 11, you have to divide out to figure out whether or not they're divisible. But the 1 by 3 is a big one. So answer the question, is 7 a factor? No, it means 7 does not divide evenly in. Guess what we're going to do? We're going to do the same thing with polynomials. So we're going to do long division. Here's what it says. We're going to take f of x and we're going to divide it by d of x. Okay? So here's what it looks like. Set it up. I'm going to do 1x cubed minus 3x squared plus x plus 5. Now, please put a note. All descending powers present. All descending powers present. That means my highest power of x is 3. I must have placeholders. I must have x squared. I must have x, and I must have a constant. That's true on the inside, and it's also true on the outside, x minus 2. I don't need to go all the way up to 3, but I also must have all descending powers present. All descending powers present here, all descending powers present here. You must have that, or it's not going to work out for you. So now, just like the numeric example, you ask yourself, and you say self, x times what gives me 1x cubed? 1x squared, correct? 1x squared. So if I take this times this, that's going to give me 1x cubed. I then multiply. Red times the first purple is 1x cubed. Red times this purple is negative 2x squared. This is where we always have an issue. I didn't add 49 over here. I subtracted it. By definition, subtraction is changing your signs. So this is 1x cubed minus 1x cubed, which went away. But this is not negative 3 minus 2. It becomes plus 2 with the sign flip, which gives me negative 1x squared. I want you to let that sink in and ask me whatever question you want up to that point. You need me to clarify it, say it a different way? Does that make sense? That I have to do a sign flip here because I need to subtract. Yes?
Is that 1x squared? Is that placed there specifically?
Yes. In other words, why didn't I put it here?
Yeah.
Because now what I'm doing is I'm lining up, just like my decimal places. I know that I've only got 2 more spots to fill to complete my division. Okay. All right, so now, just like here, we do our work, we then do the bring down method. So I'm going to bring down, let me switch to blue, the positive x. So I've got the bring down. I didn't switch any signs, I just brought it straight down. I ask myself, self, what do I need to multiply x by to get negative 1x squared? Negative 1x. Negative 1x. So now I'm in the blue. So I multiply, I get negative 1x squared. Multiply here, I get plus 2x. These are going to cancel when I switch the sign. This becomes a plus 1x. What does the plus 2x become? Minus 2x. So now when I add, I get negative 1x. What should I use for my next bring down? What was that? Plus 5. So I bring down the 5. And we're going to do the process again. Any questions to there? I will not give you more than one of these on a test, so please take your time. Make sure in your homework you're doing this. This seems to be kind of a place where people lose points. Are there questions why this is a minus 2x, not a plus 2x? We switch the signs because we're using subtraction. What do I need to multiply x by to get negative 1? X. Negative 1. Okay? Then over here I've got negative 1x. Multiply, I get plus 2. What's my remainder? Is it 7 or 3? What's my remainder? 7 or 3? Switch this sign to a plus, switch this to a minus, gives me a 3. Okay? Remainder of 3. Or this could be written as 3 over x minus 2. Questions on long division? Totally free, no charge.
Would be 3 over x minus 2.
Same thing. Remember doing it with fractions? It's just now we're expanding it to algebraic fractions. Algebraic fractions. Good? All right, here we go. Okay, take a second to read the next theorem in math. Do that up for right now. What? If f of x is divided by x minus k, the remainder is f of k? All right, so for those of you that are just sitting and watching, I'm about to blow your mind. So this is a good point to check back in. The remainder theorem. All right, in my last example, what was my remainder? So that was the last example. I had a remainder of 3. Okay, so keep that in mind. I had a remainder of 3. So if I look at what this says, find the remainder in example 1. What did I divide by? I divided by what quantity? X minus 2, right? X minus 2. So there's my X minus K. Now, in the last lesson, which is what we went over at the beginning of class today, we talked about if this is the factor, what is the 0? What is the value? My 0 theoretically could be 2, correct? So that's where we're getting the sign flip from. That the factor says negative 2, but I want to plug in f of 2. Okay? So you might want to put a note here that my factor was x minus 2, but I'm finding f of 2. So, if I do that correctly, I'm going to get f of 2 is equal to 2 cubed minus 3 times 2 squared plus 2 plus 5. Guess what that gives me? Take a guess. Yell out a number, someone. Okay? The answer is 3. The remainder theorem specifically says, think about our function notation. Doesn't that mean that the point 2, 3 is here? That's a point on the graph? Yes? Is 2, 3 a 0? Is 2, 3 a 0? No, it's not. 3 is the remainder that is left over after I divide by a factor that I think is a 0. Boom, that's insane. Okay. Yes or no? So here's my question. Given a problem on a test, would you rather do long division or substitute in f of 2 to get the answer? Substitute in, right? The only thing you have to watch is you don't substitute in the negative 2, you substitute in the 2. Does that make sense? Does anyone not know what I'm talking about? Okay, fantastic. Yes?
Well, how'd that be the answer for division problem? How's that?
Okay, look at number 1 on your paper. If in number 1 I gave you that f of x, right? And I said, find the remainder when f of x is divided by x minus 2, you wouldn't have to do the long division. You could just plug f of 2 in, and whatever you got out of the function is the remainder. That's what you could do. Right, that's the remainder theorem. Yes?
Do we have to do both of these on the test? Like long division and or can we choose?
No, it's just the fact that the remainder theorem is a shortcut to long division when you're dividing by what we call a linear factor. Okay? All right, so then we have the factor theorem. All right, so let's connect the dots. Factor theorem says, if you have a factor and you plug in the k value into your function, which is that opposite value, and you get a 0 out, doesn't that mean that k comma 0 is a point on the graph? What do we know about anything that has a y value of 0? I know I'm going a little fast because some of you are like, why 0? It's an x-intercept, right? Which means there's no remainder. It's going to fall on the x-axis. And we would say that this is a factor. All right, so now let's talk about factoring for a second. All right, I'm going to show you 2 types of factoring. Let's take 20, hold on a sec, I'm going to think of the numbers. 60. What are the prime factors of 60? What's the first thing you think of when I say 60 to break it down into? 10 and 6? Yes? Yeah. 10 and 6. Some of you might have said 5 and 12. Okay? Now, here's the idea. I took 60 and I divided by 10 and I got 6. Right? 10. But now I'm going to break each of those down. So 10 is going to break down into 2 times 5, And 6 is going to break down into 2 times 3, right? So think of this. Aren't these all of the factors that multiply to give me 60? Right? What you do now with this is the following. X cubed minus 9x squared. Is that right? Hold on, take out an x. Just an x. You take out an x, you get x squared minus 9, and then what do? You break this down into x minus 3, x plus 3. Exact same process. Algebraic factoring, numeric factoring. Yes? Okay, so now the factor theorem is going to tie into what we're doing here. Let me show you. Show that x minus 2 is a factor of this big, long, ugly thing. All right, no problem. I'm going to find f of 2. Notice the sign flip. So when I do that, I get 2 cubed minus 4 times 2 squared plus 3 times 2 plus 2. 8 minus 16 plus 6 plus 2 gives me what? Real quick, 8 plus 8 minus 16. Rearrange the order, figure it out. What'd you get? 0. Yes? So that tells me that f of 2 is 0. That results in this being a point on that graph. It came out to 0. There's no remainder. It is an x-intercept. What that tells you is that this, right here, is factorable into x minus 2 times something. X minus 2 is a factor of f of x. It's going to end up being one of these quantities all the way at the end when we break it down. Questions on that? Why are you always flipping the sign? Good question. All right, so when we yesterday, and this is going to help some people, when we were looking at graphs yesterday, and we said something crossed at 2, that was my 0. What is the factor when it's 2? You remember? Everybody knows from yesterday that it was, if you were here, that the 0 is 2, but the factor would be x minus 2. There's a sign flip. That's the reason why, because it's x minus h. Think of the vertex. It's the opposite. That's your sign flip. Okay? All right, moving on. Factor, we did all that, we did that. Okay, here's our shortcut to long division. It's your favorite. Do you remember synthetic division? Do you love synthetic division? Synthetic division is fantastic. One rule. All right, before I say one more rule, one thing you need to know. When is the only time you can use the quadratic formula? When's the only time? Yes. When y is equal to 0 and? When what? When it's a quadratic function, which means the highest power of x is 2, right? That's the only time you can use the quadratic formula. The only time you can use synthetic division is when we are you ready for this? Dividing by a linear factor. What? Dividing by a linear factor, which means what's the highest power of x? 1. I cannot use synthetic division if what I'm dividing by is a higher power than x minus or plus a number. It's a great shortcut, but it only works in that one specific scenario. So let's take a look at the example that we have. We're going to divide by x plus 3. Is this a linear factor? Yes, it is a linear factor, which means you may use synthetic division. Okay? The way this works, okay, the way it works is we're going to use, again, the opposite. So the opposite is -3. That's going to go on the outside. There's only ever one number on the outside in synthetic division. I then am going to use the coefficients. Okay? But I'm going to put a little note up here. All descending powers represented. What does that mean? Well, it means this. My highest one is x to the 4th. So I have a 2. X to the 3rd, +5. Uh-oh, I'm missing x squared. I fill in a 0 as a placeholder. -2, -8. In long division and synthetic division, you must have all descending powers represented. Okay, leave a space in your notes and draw a line. This is going to take me about a minute to explain, but when you do it, it's going to take you 10 seconds to do the problems. That's how fast synthetic division is. And this is what happens. You bring down the first number, which is 2. Multiply. 2 times -3 is, so I write -6, and then I add. I don't flip the signs like long division. 5 minus 6 is -1. Multiply. +3. Add. 3. Multiply. -9. Add. -11. Multiply. 33. Add. 25. Did I make a mistake? Are we good? I think we're good, right? And you're going to say, oh, great. We did all that work, and all I have is more numbers. But you did do something pretty spectacular. If this is x to the 4th, this is x to the 4th, this is going to be x to the 3rd, x squared, x in a number. The last one is going to be your remainder. This is known as synthetic division. Way nicer than long division, isn't it? It's fantastic. All right, now I'm going to ask you a question. See if you get it. If you're with me at this point, this answer is going to be very quick to you. Is x plus 3 a factor of this quantity? How do you know? The remainder didn't come out to 0. Over here, when we did the long division, if the remainder doesn't come out to 0, it's not a factor. Same thing, we just showed it here, the remainder is not 0. If I had plugged in a -3 for x, I would have gotten 25 out. That's the remainder theorem. All right, so here's the review of the skill. This is how you do it. Now we're going to use an example of why you would do it with what we're doing. Flip the page. We're almost done. I split this lesson in half, as you can see. To find all the real zeros of a function, you get to use your graphing calculator. Put in the function and determine any easy zeros. So you should look at a picture and say, oh look, it crosses here, it touches here, I can use those zeros. You're then going to use synthetic division to break down the polynomial. And then when you break them down, at minimum, you might have to solve a quadratic. If you have to solve something that's x to the 5th, it's not going to work. Do you have all of these listed in your notes? Yes? Okay. Those of you that are not paying attention, you can do another work, anything, please check in on this one example. It's the last one that we're doing related to these 3 key skills. Okay, so you're also going to need your graphing calculator. So pull that out, please. If you don't have it out, pull out your graphing calculator, or be able to share with a neighbor so you can see this. Orange box. Box. Red box. keep in mind what I just highlighted. I'm going to refer to them as orange box, blue box, red box. We look at the next example. X cubed minus 2x squared minus 2x plus 4. Put that into your calculator, please. For y1, plug it in. If you do it correctly, this is what your picture should look like. You're going to need to go in and do some things in your calculator, so that's why I'm asking you to do it at the same time as me. Okay, first question for you. How many zeros does it look like this picture has? How many according to the graph? How many? 3. Okay, a couple reasons we know that. One, the highest power of x is 3, so there should be 3 of them. Second reason is because when I look at this, what I don't know is, does this touch here or does it cross? You think it crosses? Because if it touches, wouldn't that be a double root and it would count twice and this would count one time? So it still would be degree 3, which is what we're seeing here with the f of x. This is where we're going to use the table function. So if I look at this, it looks like it crosses maybe at -1, 1, and 2. If I go into my table, do you notice that it only crosses at -2? That's the only place that y is 0. 1 isn't 0, 2 isn't 0, just at 2 it crosses. Yes? At 2. Okay, so at 2, that is my 0. What would my factor be? If 2 is the 0, what's the factor? X minus 2. So between this and this, I know that this is going to break down. Let me switch colors here for a second. So at 2, I have this. I know that I should be able to turn this into x minus 2 times something. I'm going to figure out that something using synthetic division. 2 is my 0, so that's my actual 0 that I'm putting in. What are the numbers I would write underneath? 1, x cubed. -2, -2, and 4. Leave a space, draw my line. Any questions on that setup for synthetic division? Yes, no, maybe? Okay, so we'll quickly do this. You bring down the 1, multiply, add, multiply, add, 0 with a happy face. Why would a 0 in the end make me so happy? Because it's a factor, and it should be a factor because it's a 0. Yay, everything worked out. I will always put happy faces there in every problem I do because it's cute and it's fun. We don't have a lot of fun in math. There it is. What the heck does this mean? Well, if the highest power was x cubed, when I use synthetic division, this reduces everything by 1 power. So this becomes 1x squared plus 0x minus 2, which means x squared minus 2 is the now next step of broken down once I've factored out the x minus 2. Okay, here's my problem. X squared minus 2 doesn't factor as difference of squares. So how do I determine the exact value of the other zeros? I take what's left. I take this x squared minus 2, and I set it equal to 0, and I solve it. Plus or minus root 2. So when it asks me, find all the possible zeros, the answers are 2, positive root 2, negative root 2. Now, I do want to clarify something because I'm sure some of you who love your calculators are going to say, but I could just go here and tell you the decimal. I want the exact zeros. Decimals are not exact. You end up rounding them. This is an exact answer, plus or minus root 2's. Plus or minus?
No, the on x minus 2 and x squared minus 2, we're doing x squared minus 2. Okay.
Because why I wrote it in blue was, you know right here, when I said I was factoring out an x minus 2, that's like me taking out this first x. I'm finding the rest of it through synthetic division.
Okay.
Yes?
Yeah.
And then I find the rest of it. Sometimes what's left here will factor real nice. You can just come up with the factors. If not, you go to quadratic formula, which is what we have there. All right, the last example is super easy. Before I get there, because I know I went really fast, what questions do you have on my work? What questions do you have on what I did, colors, anything? What should your answers look like? This. What kind of work should you have? You should have some synthetic division and then some sort of quadratic manipulation, whether it's factoring or quadratic formula or solving. This is the perfect square method of solving.
I don't know why you only do two, not the other, listing other zeros.
There's only 3 zeros.
There's three. One, two.
Why'd I put what?
Why'd you only pick the two?
I didn't. I picked 3. Number 2, positive root 2, negative root 2. That's 3.
No, like on the graph. The graph is
Yeah.
0, 2, 1, 1.41, and negative 1.41.
Okay, go to the top of the page. What's the first thing you're supposed to do when you're trying to break down a function? Look for easy zeros. An easy zero will be in the table. A hard zero would be finding intersection and coming up with a decimal. You don't want to do synthetic division with decimals, right? You want to do them with nice numbers like 2. So that's why we chose 2. All right. Example 6, last one. Here it is. Take a look. Write f of x in factored form. How many zeros do I have? 3. So I have a degree 3 polynomial. No multiplicity, very straightforward. What happens when I have 3 zeros? What do they translate to into factors? OPP, other people's problems, OPP, opposites, x minus 2, x minus root 2 and x plus root 2, where these are the sign flips, x minus root 2, x plus root 2. Okay. Do you notice that this that I'm underlining in orange is difference of squares? Yes? It looks weird because it's roots, but isn't it difference of squares? X plus a number, x minus a number. So if I FOILed that out, or distributed it, wouldn't I just come up with x squared minus 2? Which then I could multiply times x minus 2 and come up with my final answer. Now, did I skip a couple steps here? Yes, but my question is, can you follow the theory of what I'm doing with the lesson? Yes, I skipped some algebra from here to here. You probably will have another line of work, something. You may not. This would be the answer I was looking for, the last one. Questions? Nice little package, it all fits together. We can move between factors and zeros using synthetic division now. That's the big idea for today's lesson.